In example B, we can't use back substitution because I'm not told what one of my variables are. But we can use our technique from last lesson when we are solving systems of equation with two variables. Because if I kind of don't look at this top one here I have a system of equations with two variables. So what I need to do is almost not even pay attention to this top one here. I'm going to use these two to find my y and my z. And then we have one additional step of substituting in y and z here to give me x. So this is really almost no different than last lesson. So looking at my two bottom equations, you can eliminate either y or z. Now, because this first y has a 1y, y is going to be the easiest thing to cancel. So what would I need to multiply this equation by to get it to eliminate my y's in that second equation? And that's -3. So obviously here I should have stopped and said, what are we using here? I'm using elimination. I prefer elimination, especially when they're stacked, but you can use substitution here if you like substitution because of this one y, right? If you want to solve for y, we would subtract that 2z over, so we could say y equals 4 minus 2z and solve by substitution, but I'm going to use elimination here. And so now this equation becomes -3y minus 6z equals what? Don't forget to multiply that 4. So equals -12. And then I need my equations here to stack. So I'm just going to rewrite this one. And now elimination is also called the addition method. We're going to add what we have left. So positive and -3y, those are eliminated, which was the goal. So add what's left. -6 plus 7 gives me 1, or just z. -12 plus 22 gives me 10. So by eliminating those y's here, I have solved for z. So now get your y. You can plug it in to either the middle or the bottom. I can't substitute z into this top one here because then I still have two unknowns. So that doesn't help me. So I'm going to substitute this into this middle one here since it's just a 1y, not a 3y. So I have y plus 2 times z, which is 10. And that equals 4. So we have y plus 20 equals 4. We'll subtract our 20. And we get y equals -16. So now, last lesson, this is what we did. We were done. We solved for our two variables. Now with this problem, I have one additional step, and that's to substitute it into the top one and get my last variable. So now I have x minus my y, which is -16, minus 4 times z, which is 10, and this should equal 0. Again, double negative here because we're subtracting y and my y is negative. So we get x plus 16 minus 40 equals 0. So 16 minus 40 gives me -24. Add that over. And x equals 24. More than likely, this is all MyMathLab needs. It's going to say x equals, you're typing in 24, y equals, you're typing in -16, and z equals, and you're typing in 10. But me, I like ordered pairs, right? So this is x, comma y, comma z. So 24, -16, and 10. Would be my final answer. And if you're taking this class on campus, the answer I'm looking on your test. Now I have a note down here. This is the whole lesson. Okay, this is all we're going to do for section 7.1, and this is as hard as an equation with 3 variables gets. They did us a huge favor here by not giving us x values in those equations as well. we're eventually going to have 3 equations, all with 3 variables, and we're not going to end up solving those by hand. We're going to be using this RREF command in your calculator. And so I would just go ahead and not even do your homework over 7.1 yet. I would jump right into the next lesson. And the next lesson, we're going to learn how to solve systems of equations like this right here, and even honestly, systems of equation with 2 variables by using our calculator. And so I would solve all of your problems in both section 7.1 and 7.2 using what we're going to learn in the next lesson. So I would just continue on, learn your last lesson, and then solve everything in your last 2 homeworks the same way by using this RREF command.